Hi everyone, welcome back to our video series, Architecting Private AI, Infrastructure to Applications. I'm Satya Shrestha, Senior Staff Executive Services Architect here at VMware, and with me again today is Sean Huntley, one of our private AI experts. Glad to have you back, son.
Thanks, Satya. Episode 3, here we go.
That's it, man. And today we'll be diving into VMware Private AI Foundation with NVIDIA as part of this video series. So, Son, why don't we jump straight into today's topic?
Yeah, great. Last time we spoke about private AI in general, and in episode 2, we spoke about the AI application foundations. We talked about RAG, we talked about MCP, and a lot of that's going to be assumed knowledge for what we're talking about here today. I'll take it for granted that you sort of have a good idea of those things, and we're going to be talking about today how VMware specifically solves some of the business challenges, developer agility challenges, and more that we spoke about in the previous episodes. So a little bit more opinionated here from us from a product perspective, and give you an introduction to the product. And 4, 5, and 6, we have demos lined up of that. So without further ado, let's crack on. So today we're talking about Private AI Foundation with NVIDIA. And there's 3 really key things that this offering does for your business. The first is a real focus on privacy and security. Being on-prem and having a lot of customers thinking about how to secure their AI environment, both operationally and from a data security perspective, that's a really, really key focus of what this platform can do. The second is we really want to make sure that infrastructure management is as easy as possible. And that really means uplifting the VCF product to make sure that GPUs are treated as a first-class citizen. And thirdly, we're really focused on streamlining developer services for deploying models, making it easier to build AI agents, and connect all those 2 other pillars that we just talked about. And all with the focus of making AI really easy to adopt. We want to make it easy to get this AI into your business and easy to use, and make it with a lower total cost of ownership than other solutions that you might see out there on the market. It's a AI native platform. That's what this does for VCF.
That's it, yep.
So in traditional environments, we have this pattern where compute, network, storage, security, monitoring, every single time you go through an update, you have to take that whole application through that process all over again. And every time you have to create a ticket or manually do these sorts of processes, it slows you down. If you're trying to deliver things quickly and iterate quickly, you need to have a really fast time to feedback. And so bringing in the capabilities to start to think about how we automate and make our developers as agile as possible in a on-premises environment, that really adds a whole bunch in terms of service delivery and orchestrating our environment to make that application delivery as quick as possible, right?
Right, yep.
So to do that, what we're really concerned about here is how to upgrade our previous environments from an operating model that we've had in the past to one that is a cloud-like operating model, where we separate out these 2 distinct parts of the business. One is the admin, which are really focused on delivering services in a frictionless manner, making sure that we're meeting our governance and compliance needs, setting the right guardrails for security and more, and how the infrastructure can be consumed. And then the consumers, right? How do I get access to the tools I need, whether it's a Kubernetes cluster, a VM with a GPU attached, deploying a model, you name it. And that's the sort of consumption experience that makes developers and consumers across the board, DevOps teams, whoever, more effective and more agile. And that's why we need to go down this cloud operating model.
Right. So here, the persona admins, we're talking about cloud admins, private cloud admins, or infrastructure admins, right? That kind of
platform architects, you name it, right?
Yes.
Yeah. So to build that private cloud, we have a few level set things here that we need to think about. So the first is the virtual infrastructure that all of our customers today know and love. You know, vSphere, ESXi, vSAN, NSX, all of this base component that we've talked about for a long time. On top of that, we have our control plane, which we call supervisor. And this enables us to deliver network services, storage services, VM service, Kubernetes, all of these different types of services in the same way that a public cloud might. On top of that, what you're seeing us do is add more and more rich services for databases and AI on top of that, and more will come over time.
Yes.
On top of that, we need to then think about the management and governance of how we actually consume those services and the underlying infrastructure. And then finally, the consumer wants to be able to use that in any way that they possibly might, whether it's a CLI, a GUI, an API, etc. Right? And so by building up all of these different pieces, that's how you're going to have that cloud operating model.
Right.
Where does the AI part fit into that stack? Well, as we previously discussed, you have that sort of rich infrastructure layer of compute, storage, networking, and now GPUs as a first-class citizen. We don't have to think about retraining our platform admins and the IT architects our teams already know how to automate and operate an infrastructure platform and how to secure it. On
Yep.
top of that, we have infrastructure services. As I mentioned before, VMs, containers, network, we're seeing database as a service get more and more popular. And then on top of that, we have capabilities around virtual GPUs. So we can start to carve up these GPUs and provide them to different teams without the business as part of containers or VMs, Kubernetes clusters, and then model runtime. So we can deliver models as infrastructure services as code. All of these capabilities here, you can see this layer, we can deliver as infrastructure as code, which really makes it a resilient platform for delivering these types of services.
Right. Right.
On top of that, we have these rich AI developer services for vector database, data indexing and retrieval services for breaking down data silos, APIs for inference with those models that we've deployed, gateways and services for building agents really quickly.
These are all coming as one single platform, right?
That's right. And that's what we're really excited about, because at our conference and Explore in 2025, it was announced that the VMware Private AI Foundation is now a native part of VMware Cloud Foundation in version 9.0, which is fantastic news for all of our customers who want access to this, who want to deliver AI workloads and start to run these sorts of capabilities. It's fascinating.
Absolutely. And before this, our customers, they needed to buy this as a separate licensing, isn't it? It had a separate licensing, and then it wasn't part of the overall VCF platform, right?
Right. So yeah, you used to need a separate license from us, but now it is an AI native platform. We have the VMware Cloud Foundation, which from onwards releases is going to include all of these capabilities. It is an AI native platform. So we have the VMware Cloud Foundation components around multi-tenancy, resource scheduling, workload security, the GPU monitoring and operating the infrastructure. And then on top of that, we have all of these private AI capabilities for delivering complex infrastructure objects, storing models, delivering models, as well as agents. And then on top of that, we have a rich set of software services from NVIDIA for delivering NIM, inference microservices, blueprints for different types of workloads, and more.
In this chart here, when you say we bring this VCF with private AI, do we still need to get any licensing from NVIDIA, or how does that work?
Yeah, so the NVIDIA AI Enterprise license is still required, which is a key component here. With VMware Cloud Foundation and then the NVIDIA license together, this is a joint solution that we deliver together. So those are the two components you need, as well as some GPUs to get going. And then you're going to be able to run all sorts of AI workloads from there on.
Right, right. Okay.
Cool. Now we're going to go into a little bit more detail. We're going to start to talk about the privacy and security angle here. Here are the few key pillars that we're going to talk about. The first is how we actually start thinking about storing models as part of VCF. How do we think about the governance and security of those? How do we onboard them? NVIDIA's got some great software for security patching through their AI enterprise. So we can start looking at the different models and delivering continuous monitoring for these different security patches and CVEs that come out as part of their solution stack. And we also have air gap support as part of this solution. So you can run the VCF stack with all of the AI components completely air gapped for your private and secure data center.
Right, right.
So first of all is model store. So the model store is where we store models. It's in the name, right? And what we want to start thinking about here is if we're connected to the cloud, having a corporate and security approved set of models that our teams can start to pull and use. It's the same as what we do with containers, right? It's a registry, and that's why we've gone to Harbor for this sort of solution. We can have dedicated projects with models that our security teams have approved, scanned. We can access via CLI and API and integrate with our CI/CD. Start to have enterprise control over these new type of digital assets. It's often quite new for organizations to manage.
Right. So are these models usually in a virtual machine form factor, or is it mainly in a container form factor?
Models can be delivered in multiple ways. The underlying asset is they come in all sorts of different data file formats, but they are not necessarily containers, nor are they VMs. They're actually just a whole bunch of data in the same as any other file that you might store on a file system. What we need to be able to do, as we discussed last time, is be able to have the tools to be able to use that data with what we call a runtime service to actually deploy those models and actually make them productive. And that's where it starts to come in a VM or container format. Now, the NVIDIA side of the house that we talked about, we can also start to store these inference microservices, pre-built containers for inference in Harbor and protect them here.
Right. Okay. This could be just a big data file that is sitting on your model store, and then that model is being used by many other consumers, right?
Yeah. And so as you pointed out, it's a big data file, right? And so instead of reaching out to cloud to go and download this file, we can then have a local repository of it and, save a lot of round trips and a lot of download to our data center, right? And we can deliver these services a lot quicker that way.
Mhm.
We can then break it down into different projects. So we can sort of garner access control in different ways here. Add RBAC. We might have a project of development unapproved models that we're still waiting for the security team to check and validate. We might have a specific project that is for product teams with approved used models that we can go and run. We might have our dedicated corporate models that are used for internal chatbots, etc. And so we can divvy them up and control access to these different models with RBAC, which is really powerful for our security model.
Right. So they can architect it as they see fit.
That's it. That's it. Here's an example onboarding workflow for how we might want to download models and put them into our environment. Lots of different sources of models, including Hugging Face, NVIDIA, Mistral, Meta, we can go pull from. And if we pull that model into our environment, we might have a VM, in this case, a deep learning VM, in its own dedicated DMZ namespace. And here we can start to evaluate the model, see if it's fit for our purpose, and then do some standard security testing. There's lots of different tools out there for this, such as Giscard is a great open source tool. And then we can then push that model to Harbor, an unapproved or approved state for further testing, etc. And then we can get into when we actually want to consume that in our dedicated AI namespace or a project namespace, we can start to use some of the other software tools that we have available to start to run the model and build agents with it relatively easily.
Now, this task here, pulling the model and pushing the model and all these things, which persona does it? Is it mainly the infrastructure admins, cloud admins, or is it your application developer? Who's that persona?
Yeah, it really depends on the size of the business that you're in. I would say in a typical large enterprise, we're going to have an ML or an AI team who understands models and knows how to run them. Anyone who's starting with their first AI model might do this step. Onboarding it might be as simple as, hey, I don't have heaps of knowledge about security scanning, or I have this corporate tool that I pulled into my environment to scan models. That might be the workflow. But here I would imagine it's a AI operator, AI ML ops person to go through this process. Yeah.
Cool.
And then on the other side, it might be the developer pulling the model, or the platform team who want to run a service on behalf of the business that pulls the model.
Right. And we're talking mainly about the open source model here at the moment, right? Not proprietary.
Yeah, the only models you're going to be able to download into your environment are open models from providers such as Hugging Face or NVIDIA.
Right. And we can even do the DeepSeek, right? If our customers choose to do so.
Yeah, exactly. So DeepSeek's another example of a great open model that's available to go and use in your environment today. Speaking of models, one of the things that we talked about before was streamlining model deployment and these sort of rich developer services that we wanted to deliver. Here in this section, we're just going to talk through what it takes to deploy a model, how we can start to build AI agents with the platform, as well as how we might want to deploy models through the NVIDIA ecosystem with their pre-built inference microservices here. So the NVIDIA inference microservices there's a rich catalog of these for all different sorts of use cases. And instead of having to make sure that you can run the model yourself, they come as a pre-packaged container with the runtime, and oftentimes optimized for the specific GPU that you might have purchased for performance. This is a great way to get started with a whole bunch of different use cases, and I'd encourage you to go and see the build.nvidia webpage for more details on all of the different software side that NVIDIA offers.
Right.
On the Private AI Foundation side, we offer a service called the Model Runtime Service, which really makes it easy to take the models that are stored directly in Harbor and deliver them as a service. We can support multiple different models, such as a large language model, an embedding model, and different inference engines, which I'll get into just here.
Yep.
There's two types of models. A completions model is a large language model, effectively. And most of these are, like you mentioned before, DeepSeek or Llama, the GPT OSS. Here we deploy those using an underlying engine. In this case, VLLM is the main one that we're using here.
Yep.
And now, if we recall to the last episode, we needed another type of model for vector embeddings and retrieval augmented generation, and that's an embeddings model. And here we're supporting an engine called Infinity to support these different sorts of models like Qwen, Gemini embedding, BGE. There's a few different available on the market. And so what this really allows us to do is ship a model as a service. We can deploy it in this self-service GUI or as infrastructure as code to deliver models and an API that is capable there. So to do that, this model runtime, when we ship models, has its own API gateway where we can have multiple different models here but running behind it, whether it's Mistral, Llama, whether it's running on CPU or GPU. And the cool part is that it's OpenAI API compatible, which a lot of my customers that I speak to, they might have developers working in the cloud with the OpenAI API interface, and they're starting to use a lot of tokens, and their workload or their application is starting to perform really well. They're happy with it. and they have GPUs available on premise, and they can then migrate that workload directly on prem, where they're going to be able to really get serious about inference and lower the total cost of ownership for that application.
Right. So this API gateway, which is interacting with multiple systems, how does this get deployed? Is it deployed by the cloud admins? How does it, I mean, the whole thing hooked
Yeah,
together?
well, so it's actually a service, a supervisor service as that is delivered as part of the private AI services. So once we enable this service, there's a little bit of setup that the platform admin might need to do to set that up.
Yeah.
And once that's set up, anyone can go and self-service deploy a model, and this API gateway will scale based on the automated requirements that are here, right? So you can deploy 3, 4, 5 models, however many that your infrastructure will handle, and then this gateway will be able to handle that.
Okay, cool.
A lot of questions around authentication and authorizations come up.
Yeah.
That whole privacy and security thing we take seriously. So we really want to make sure that only authorized users and apps can access those models. OpenAI compatibility is really important so that we're standardized across all different platforms. We want to make this as easy to use as possible.
Yes.
And the cool thing is we can actually change the underlying model here. You can go
Wow.
and test the performance of Llama 3 versus Llama 4 or the new DeepSeek. And we can go and see, oh, is this model performing better with my app, and start to evaluate it. The API interface is stable, which is really powerful. And then if our application really starts to get used and we really have multiple different applications maybe using the same underlying large language model, we can
Yes.
scale to meet all of that demand by scaling that out with replicas. And this whole service is actually built on VKS, our Kubernetes service, to deliver these sorts of capabilities.
Right. So all these capabilities, our customers, they don't need to create it themselves, right? It is part and parcel of VKS itself.
Yeah, that's right. So it's part of the private AI services, which underlying uses Kubernetes to run.
Yes.
There's a lot of my customers have started to build these sorts of capabilities over the last few years because they've needed it internally, and now we're seeing lots of migrations to this platform because it's more powerful and it has all of the richer features around support and scalability that organizations need.
Exactly. It's part of the VCF platform itself, so they don't have to think about heavy lifting, upgrades, patching, all these things as well, right? So everything is
Yeah,
already in.
all of the resourcing around that. Yeah, absolutely.
Yeah.
So I was sort of mentioning about scaling and how we sort of test across multiple models. I wanted to give you a really cool example here, which
Yeah.
was that how do we start to upgrade one of these models? As part of that gateway, when we deploy a model, we can specify its routing name. And if we use the same routing name across two different models, so let's say Llama 3.1, and then we want to move to Llama 4, we can use that same routing name and then migrate over, and our users and applications aren't affected whatsoever. Their experience is maybe the inference and the performance of their application just improves overnight without them doing anything. And this is a great example of how we can keeping that consistent interface is really powerful.
And that's very transparent to the end user. They don't even know they have switched from Llama 3.1 to 4.
Yeah, that's right.
Awesome.
The thing that's really important about driving your infrastructure as hard as possible, GPUs are expensive, is how do we start to share GPUs and share models across different applications? Now, if you recall, we spoke about this in the last episode, where what we really want to start thinking about as an IT team is how can we provide models as a service, not answering every call for a GPU and say, hey, this team wants a GPU, that team wants a GPU. Instead, a lot of the time, they just want an LLM API. What we really want to be able to do is have a consolidated set of models that are high performance that we can support with our GPUs and then share them across multiple different organizations, but without the data security concerns. This cross namespace model sharing, while preserving the data privacy and isolation, is a huge capability that we announced at the recent VMware Explore conference.
Right. So that means that they don't have to have multiple models for multiple, or just single model properly shared, and then the same storage, same platform, everything, right? So a lot of saving, optimization.
Yeah, exactly. And then if you want to start to scale it, you scale it with replicas, right? And then you can do it based on demand. And this is how you can start to drive down the costs and support more and more workloads with the same infrastructure.
Yeah. Yeah. And then there's the point you spoke about, the governance, the security, all of that's already there. Yeah.
Exactly. So your security team's already approved it. We just need to start scaling it out. And importantly, if organization 3 wants to come along, they don't have to go through the whole approval process of what model do we want to run, all this sort of stuff. The API is there and available for them to use, and their applications can start using it. They can develop with those models that are already running, and then they can move to production seamlessly. And this is a cloud operating model, right? People in the cloud are used to using ChatGPT API, the OpenAI API, and just consuming and building really quickly. We can start to deliver that same sort of private cloud experience on premise here with VCF, which is really cool.
Really cool. Yeah.
Okay, so once we've got models running, we need to start thinking about how do we start to augment that with our data? We've talked about RAG, we've talked about MCP, we've talked about agentic workflows. So here, what's really powerful is as part of one of those services that we were talking about earlier, there is a service called Data Services Manager. Here, there's a capability to use database as a service requests for shipping PostgreSQL and an extension for that called PG Vector, which effectively transforms Postgres into a vector database. Once that capability is up and running, then we can start to think about, okay, that we have data here, we have our database set up. How do we start populating it with data for our AI agents to start to consume?
Right.
And that's where one of these other rich services that we've added comes along, which we call the data indexing and retrieval service. The idea here is to break down all of these different data silos, connect your enterprise data to it, chunk up that data and put it in that database, ready for an AI agent to start to consume.
Right. Where does these things get stored? Is it in the vector DB itself, or is it?
That's right. That's right.
Right.
So there's three key concepts I want you to get your head around here.
Yes.
The first is a data source. A data source is where we're going to get this data from. It could be a local file, it could be SharePoint, it could be Google Drive. And we're going to pull data from these different locations. And then we're going to process that into a knowledge base. So if we connect these, all of the text chunks and the vector embeddings here make up a knowledge base that we can go and connect to our different AI applications for a RAG purpose. The process of turning the data that we've pulled from a data source and transforming it into useful vector embeddings and chunks in a knowledge base is called data indexing. That's the process that we use to transform the data.
Right.
Now, all of those pieces come together in this platform. Here we have a great set of different data sources that we might want to consume from. So SharePoint, Confluence, Google Drive, S3 API compatible object store, which by the way, at Explore was also announced VCF is going to start supporting, which I'm super excited about. We need to be able to go and pull that data. So there's a whole crawling and fetching phase that's done by this tool. So we can start to, again, think about all these different data silos that we're breaking down here. You might have data that's only accessible to Confluence and then Drive, and then how do we start to connect them and learn from all of that different data, right? So we can go and crawl and we go through that indexing process, including with local files. And we're going to break that up into metadata, which we go and store in our PostgreSQL. We can chunk all of that data, which means we're just going to split all of the data into text chunks. So you can see a bunch of Latin that's been split. And this might be sentences, it might be how many words or characters. And then those same text chunks that we've split up, as we discussed last time, we're going to go and turn them into vector embeddings. And once we have those, we can also go and store that in the PG vector part of Postgres. So we have our database and all of our metadata set up, ready to go. And effectively what we've done is broken down all of those different data silos.
You're right. So once all this scrolling and fetching is done, as I can see in this slide, is all of those things are stored in knowledge base and some part is stored in vector DB. Is that how it is?
Yeah, so the knowledge base is the sort of collection of all of these things. The entire knowledge base is stored in that Postgres database. The actual files themselves are never stored in the database except in the sort of text chunk format. And that's because these are going to be changing. And in fact, as part of the product, you can go and change how often this crawling and fetching happens. So you connect to SharePoint and you say, okay, on every Sunday evening at 11 p.m., go and grab this specific SharePoint folder.
Yes.
And see what's changed. Has it changed? Okay, well then can you go and replace the changes and populate my database today? So it's always staying up to date. Always got the latest data.
Right. And then the other question is, now once this knowledge base is set up, can it interact with multiple models?
Yeah, totally. So once we've set up this knowledge base and we've got it stored in our local database, that's where agents come along. To connect the LLM, which is just a tool for inference, and the private enterprise data that we've stored in our database here, we want to use an agent. Here we're going to connect them here with this part of the platform. And so you can see here that we can deploy multiple different agents and we connect them to a knowledge base that is stored in that same vector database and then have the different access controls so that that model one here can only connect to knowledge base one. So it might be, a specific section of Confluence and a specific folder of SharePoint. And that agent is only using that specific data. And then the same is true for, the agent number 3 here. It's got the schema for knowledge base 3, and it's going to only be able to see the data that comes from knowledge base 3, which in this case might be one part of my object store, a part of Google Drive, and a part of Confluence. So we can start thinking about independently constructing these knowledge bases for different applications. We use the same underlying infrastructure to make it really scalable though. So a vector database here and a large language model on the other side. Now, if you do have a more strict tenancy requirements, obviously you can split this out you don't have to do it this way, but
Yep.
this is one way that we can start thinking about consolidating on the infrastructure without sharing data. It's really important to point out here that these agents can't see what the other agent is doing, but they
Yeah.
are using the same underlying large language model and vector database.
Yeah, this is very nice. And then the same data, depending on how the architecture is, right? It can be used by, like you said, multiple models, different agents doing different things. Yeah, all this
Yeah, it becomes
authorized.
really powerful. Yeah.
Yeah, very powerful. Yep.
To make it even more powerful is another announcement at Explore was that
Yes.
in an upcoming release, we're planning on supporting model context protocol. We
Nice.
discussed it briefly last time, but this is interoperability for the enterprise. You can connect multiple, I think there's hundreds of different MCP servers, model context
Yep.
protocol servers available now, some for Slack, some for Postgres, ServiceNow, GitHub, Oracle, you name it. There's an MCP server, and in fact, there's different web pages that you can Google for all the different MCP servers out there. And our agents will be compatible with any of those MCP servers that your organization delivers.
Yeah, and you come to think of it, our enterprise is already rich in all these things that you have mentioned in this slide, right? And they already have petabytes and petabytes of data sitting in there. And if you can consume this just with this MCP protocol, things will be much, much easier. Very, very neat. Yeah.
Yeah. And the really cool thing is that we're starting to think about these MCP servers not just as for consuming data, but as we talked
Yep.
about last time, agentically taking action on the data as well. One of the key things that we're making clear as part of this is that we're very clear about the access control and the security model of these. It's really important that the agents here are kept within, the right RBAC controls of how they can interoperate and access and manipulate data here. And so a lot of enterprises experimenting with this will start out with the training wheels on in terms
Yes.
of what they allow these models access to and do. And then as they get more comfortable with the guardrails, then do more and more.
Yeah, sounds good. Yep.
Cool. So we've talked about the developer side, but now it's really time to talk about the infrastructure side. All that's really well and good, but we need to make sure that our infrastructure can handle all of the different types of developer tasks that we might want to deliver. So we've talked a lot about Gen AI, but here we can also talk about the different sorts of infrastructure and making sure that it works really well. So one of the big problems for large infrastructure and investing in GPUs that I've seen across countless customers is that they'll have delivered GPUs, but one team will be hoarding them, even virtualized. They don't even know, oh, well, I gave this to Tom's team last week, and they actually, are they using that GPU? Are they making good use of it? That's a really important question for us to answer so that we can start thinking about reclaiming it and sharing it amongst multiple teams. The other thing is being able to deliver different VMs or Kubernetes clusters out of the box, out of our catalog, so that we can self-service, say, a developer wants a VM with a GPU connected with all of their data science tools already installed. Self-service click, yes, go and deliver that. The same for Kubernetes clusters, the same for self-service access to databases. So we need to make the infrastructure management be able to deliver this sort of capability.
Yeah, sounds really good.
So to get to the sort of infrastructure piece, I just wanted to give a quick introduction to how we start to think about virtualization for GPUs.
Yep.
On the left-hand side, we have CPU virtualization, which is a well-known. It's been around for a long time. We have the server, we have the hypervisor, and we can run multiple different applications here. The difference here is with our partnership with NVIDIA around virtual GPUs is that we can have an NVIDIA certified system and the NVIDIA GPU, and there's two key parts. We have the hypervisor, but on top of that, we have a host software, which is a driver for vSphere to support those virtual GPUs. And then we also need a guest compute driver. So there's two drivers that we actually need to install. One is in the guest and one is on the hypervisor. Part of that sort of delivering infrastructure objects, whether it's a Kubernetes cluster or a VM, is we need to make sure that we have the right drivers installed for those underlying guests so that they can make use of the actual virtual GPU that they're going to be given by the platform.
Right. Okay. So who installs those drivers on guest OS? I understand about the hypervisor, but in the guest OS, is it mainly coming through the registry? How does that work?
Yeah, it's actually really interesting. So that's one of the key reasons why we've tried to innovate in this space as much as possible, because I've had customers come to me and say, "Hey, my team want to deliver VMs or Kubernetes clusters with GPUs attached, but every single time I get a ticket for a GPU, I have to go and install the virtual driver in that guest, right? The hypervisor, it's already installed. They did that as part of installing the GPU cards themselves, but installing it in every guest every time there's a ticket and then installing the right software in that VM, etc., that becomes painful to manage, right? And it's something that we should and we do automate as part of this platform. So we have catalog items specifically tailored that understand your underlying GPU and the drivers that are available. We'll pull from those registries to install the right driver so that self-service delivery of these sorts of compute objects is possible.
Nice, nice.
Yeah, makes it a lot easier.
Yeah, absolutely.
So here is a few different types of configuration. So there's one which is dynamic direct path I/O, which is effectively a type of pass-through where you can have one VM to many different GPUs. So this is VMware native. It's been around for a little while, but you can have up to 16 GPUs directly pass through to a virtual machine. On the other side of the house, if you want to start segmenting GPUs into virtual GPUs, you can have multiple different configurations here. So the first is the same as the left-hand side, which is we can have up to 16 GPUs connected to an individual VM or Kubernetes cluster, the underlying worker. Or we can split and share a single GPU across many different workloads, whether it's Kubernetes clusters or VMs.
Right.
And there's two different ways to do that, and different cards support different capabilities here. And there's different performance trade-offs on which one you might choose. But there is a time sliced mode where the GPU is shared in a sort of every set period of time, we'll share the compute. And then there's another one called multi-instance GPU, where we effectively reserve a small portion of the GPU memory for a specific workload. And this gives more isolation guarantees around the workload as well. So those are the two different types of modes.
So in this mode, when would someone use that pass-through dynamic direct path I/O, and when would someone use the NVIDIA vGPU slicing and dicing sort of thing?
Yeah, so the dynamic direct path I/O is relatively limited in some ways. Pass-through gives you some performance aspects that are quite handy. DRS, our resource scheduler, will do initial placement, but it doesn't support vMotion. So having the vGPU side of the house is going to be really powerful because you can start to vMotion these VMs or Kubernetes clusters around with a GPU attached, which is really, really powerful. And then again, if you want to slice them up, carve it up into 4 different sub GPUs and give them to multiple different workloads that don't need as much memory than a whole GPU, you can do that. Yep. Cool. Speaking of vMotion, there's been some fantastic improvements on the vMotion side. We've seen great performance improvements in VCF9, such that you can vMotion an entire large language model with a 48 gigabyte vGPU profile, 48 gigabytes of memory, that is, with a 2-second stun time, which is incredible performance for keeping those LLMs active, or any workload on top of that GPU active, while we might move a VM from host to host for service maintenance, etc. Right?
Yeah. This is great for high availability for sure. Yes.
Yeah. The other thing that we start to think about in terms of service delivery here is how we can start to reserve these different GPUs. So previously, we didn't support GPU reservations. And in VCF9, we support this capability where if we want to deliver, for an example, an 80 gigabyte vGPU profile, and we have a part of it on one host and a part of it on another, we might have to manually go and try and configure where that workload's running and vMotion them and handle all those issues. But now we can start to think about the placement and make reservations for that 80 gigabyte workload so that that's there reserved. Now, when that new workload comes along, because we know we've given that capacity to an individual team for running a large language model, for instance, that capacity is reserved for them. So they're not going to have this sort of fragmentation issue.
Yes, right. And then that also gives them some extra performance, I guess.
Yeah, exactly. Well, it's really just so they can actually even schedule the workload, right? Because otherwise they wouldn't be able to schedule it.
Yeah.
I mentioned before, visibility. If you don't know how your organization is consuming your infrastructure, you don't know how to make sure you can get the most out of your infrastructure. And so in VCF9, great visualization directly here in vSphere of how many different vGPU profiles are being consumed here. So you can see in the picture an A100 with a 2 gigabyte profile. We have 8 consumed instances. We've got 6 left, and get an idea of how much capacity that we've got left based on the different profiles that we've got available, which is really handy to sort of understand how our infrastructure is being used and how we might start to think about consolidating it. And if we want to go that next level deeper, we can go into VCF operations and start to look at how our GPUs are being consumed, how the vGPUs are being consumed, the performance of those different profiles, the performance of an entire GPU cluster, the memory, the temperature, all of the different utilization statistics that you could want to make sure that you're running this AI cluster as streamlined as possible.
Excellent. So these metrics are available both in vCenter level and as well as advanced metrics on VCF operations, right?
Right. The vCenter side here is really about a bit of capacity planning and reducing admin time. So you can sort of understand your entire cluster's GPU footprint rather than clicking on every host and saying, okay, I've got this VM connected to that workload and the GPUs connected there.
Uh-huh.
Instead of doing that all on host by host basis, this is a cluster level visualization of
Yep.
how it's been consumed. And then
Mm.
if we want to get into the deep metrics, that's where we're going to see temperature, memory utilization, compute utilization in the operations console.
Yep. This is really cool.
Yep. The next thing that we've done to make the day zero really easy
Mm.
is we want to have a rich catalog as part of your VCF automation of catalog items that you can go and deploy from day one. I mentioned this before, but if those teams want a VM with a GPU connected and different data science tools, or a Kubernetes cluster with the different tools enabled and the drivers already installed so that we don't have to go and start doing ticket management for every part of it, we can really get to that cloud operating model. There is a quick part start that understands your infrastructure, understands the different capacity and performance needs of your organization, and will build those templates for you and hold your hand as you do it, which is really powerful to start to get your hands on these capabilities and get access to those GPUs and make them useful as quick as possible.
Yeah, so pretty much like a self-service catalog where the end users or consumers can go and deploy whatever they want from there, right?
Yeah, exactly. So the catalog's already populated. They're
Yep.
great templates for you to start to customize to your business's needs as well.
Excellent.
Here's an example of an AI workstation in the catalog.
Nice.
Cool. So here we have the key announcements from Explore. Some of them we've already covered, but here I just wanted to cover a few more. The first is this direct path enablement of GPUs so that we can get exclusive GPU access to one or more VMs and Kubernetes clusters. So you
Yep.
can use the whole GPU how you want, right? The other thing is the support for advanced networking with NVSwitch and NVLink with HGX systems. So if you want to start to build a large inference cluster or a training cluster, HGX has started to become one of the really great platforms of choice. So you can support really, really large scale. We also announced support for the Blackwell B200 systems, which is another GPU on the market, which is really cool.
Yes.
One of the other ones is also the RTX 6000 Pro Server Edition was also announced. And then finally here on the hardware side, we have support for high-speed networking for those enhanced direct path I/O capabilities. So if you want to have a scale out of GPU to GPU communication across
Mhm.
multiple hosts with SmartNICs, it's really powerful at that scale as well. So this is an AI native platform from the hardware all the way up to the software and developer services.
Yeah, and then it looks like all these features are mainly related with highly performant AI systems, right? So this is
That's
really
right.
cool.
Yeah,
Yep.
it's an AI first platform.
Yes.
So here's an example of that HGX system. Put in
Mhm.
a pretty picture of what it looks like, right? They're large cards, and yeah, it really supports a lot of scale.
Yes, works together with NVSwitch. Yep.
Yep. Here's an example of what that multi-host capability looks like. So
Nice.
the real benefit here is that you can support all of that vMotion capability that we were talking about before
Yep.
with ultra low latency and
Uh-huh.
direct pathways between the GPUs. So RDMA is a fantastic technology for getting this GPU to GPU communication going.
Nice.
Cool. The other one that we announced, which is really, really powerful, is we talked a little bit about MCP. We also talked about an intelligent assistant for VCF. So this is to make your experience of using VCF as a platform AI native as well. So the intelligent assistant built into the VCF product will understand all of the different Broadcom knowledge bases and
Nice.
be able to answer questions about the product, which is really, really powerful so that you can get hands-on experience from our knowledge and make it useful to yourselves and understand the documentation, your product version, and a whole bunch more to make operating your infrastructure a lot easier. So AI, not just in the platform, but as part of the platform too.
I was about to ask, it's pretty much like a chatbot where you can chat with it and ask different questions around your infrastructure, whether it's
Yep.
AI or not, right? Yep.
Yep.
Mm. So how does it actually work, son? Do you have a demo that we can have a look at?
Yeah, so here's a recorded demo from the Explore conference with an example of what this would look like.
Uh-huh.
So you'll see on the right-hand side the intelligent assistant bubble here. We can
Yes.
start to ask it questions about our infrastructure. We might want to explore the following areas for the different documentation. Gives us links to those so we can go and grab that. If we want to find a specific part in the product, it might say, "Hey, where is that GPU utilization?" It's going to go and find us this dashboard that I was talking about before in terms of the GPU operations here.
So direct interact with the system there. Yeah.
Yep. And we can start to see the GPU VM. I found these problems. What are some sort of issue resolution stuff I can try?
Mhm.
And here we've got blogs, docs, different knowledge bases, and more. And
Excellent.
so over in the vSphere client itself, we can go in and take a look, vMotion that VM,
Yes.
and then go and see that we've gone and the performance of that GPU has reset and it looks much better now.
Nice. Nice. So when is this capability actually coming on VCF 9?
It's at Explore. I think they said it was in an upcoming release. So
Right. Okay. Cool.
Yeah.
Pretty soon.
pretty soon.
Mm-hmm.
The cool part about this stuff is that it actually runs on those same capabilities, the model runtime and agent builder services that we deliver and that customers can use, right? So it's really a testament to how powerful the technology is that we can use it to deliver AI services ourselves as part of the product.
Yeah.
Cool. So just to give a quick overview of everything we've talked about today, we talked about privacy and security. We talked about how we start to secure models. We can start to scan them. You can have privacy and security of your own air-gapped environment. NVIDIA does great software and security patching. We talked about infrastructure. We can make those GPUs really easy to track, understand how the even individual profiles are being consumed. We make it really easy to deliver databases, including vector databases.
Yeah.
Get that quick start going for all those different blueprints for AI Kubernetes clusters and VMs. And then we can start to deliver all of those different developer services around models as a service, agents, MCP, as well as high performance inference containers from NVIDIA as well.
Absolutely, Matt. It's like you said, right? AI native platform. There we go.
AI native platform, right? Here's a few more we talked about across the session today. So without further ado, thanks, Satya.
Awesome. And I really enjoyed working through this VMware Private AI Foundation with NVIDIA together with you. And we saw all of its capabilities and also a little bit of future roadmap. So everybody, be sure to join us next time where we'll be working through a demo on building and operating private AI platform. The exciting time is ahead of us.
Demos. Yeah, everyone's keen for demos. I'm keen to record those. So see you next time.
Thanks, Son. And thanks, everybody. Have a good one. Bye.
Thank you. Bye.